Hello, in the last videos we discussed many problems on greedy algorithms. Let's discuss the next one. Here is the question, read it and give it a try. Teacher assigns random numbers to n students represented in an array to pair students for a project. Two students can be paired whose product is not a perfect square. Any student can be part of at most one such pair. Find the maximum number of pairs that can be found after changing at most k numbers assigned to any positive integer. That means that any k numbers can be turned to any other integers, not all to the same number. We can understand that from example. So to any positive integer, it means that any other positive integers, but not a single one. We can make single one also, but it says we can change to any other number. For example, we have this. Let's discuss example after. And so let's assume that the given array is this one: 4, 12, 25, 25 and 45, and k is 1. So we can change at most k numbers to any numbers, and finally we have to return the maximum number of pairs we can select. Maximum number of students we can pair them. The constants are n is up to 1 if I. So let's discuss how we can do this. For example, we can pair 12 and 20 because 240 is their product and it is not perfect square, so this can be a possible pair. And we can pair 4 5 also because 20 is also not a perfect square, and we cannot pair any of these two because 20 into 5 is a perfect square, 5 into 45 or 20 into 45, all these three are perfect squares. So now we have to use k. For example, let's change 20 into 11 and then we can pair these both. So now the answer is 3 because 12 and 20, 4 and 5 and 11 and 5. So 45 is left. So the answer is 3. And this is the maximum possible answer and we have to return 3. So in this way we have to find the maximum number of pairs we can select such that the product of every two is not a perfect square and k numbers can be changed to any other numbers. So for example, let's take three random numbers and we can think how to select the pair optimally. For example, we have 3, 11, 14 in some random positions, and now we are thinking about 3. So 3 can be paired to 11 also because 33 is not a perfect square, and 3 can be paired with 14 also because 42 is also not a perfect square. So can we randomly pair 3 with any other number, 11 or 14, or this will affect our answer? Obviously it will affect our answer. Let's check some examples. For example, this is the first array and we are thinking about this 11 and this 14, this 11 and this 14. So for example, in this case, if we try to pair 3 and 11, it is better, it is correct, because 33 we can form a pair and 154 is also not a perfect square. So we have two pairs now, which is the best one. But now we cannot pair 3 and 4. We cannot pair 3 and 11. If there is this, we cannot pair 3 and 11. Why? If we pair 3 and 11, we cannot pair these both 14 14 because it is a perfect square. And here we must pair 3 and 14 so that 11 and 14 will also be there and we will get an extra pair. Even here we cannot pair 3 and 14. We must pair 3 and 11 only so that we can get an extra pair. So from this we are able to understand that for a given number it is difficult to assign which number to be a pair if there are many possibilities, because here we have to pair with 11, we must pair with 11, and here we must pair with 14. So we cannot decide which number to pair with. So now let's try to simplify or break down as much as we can so that we can try to get an idea. So for example, what are the things that we can simplify now? Firstly, the size of array, and secondly values only, right? Because k, it is given, we cannot change it. And so obviously first we have to think of size of array and then the values. Only these two are the things we have in our hands. So let's come to size of array. So given the number of size, if we find the answer for example, let's say the given array size is 10. For example, if we find the optimal answer for first 5, and if we for example, we find the answer for first 5, so will that be beneficial for finding for final answer? It may or may not be right, because here subarrays don't matter. The only pair we select is matter. So so we cannot find answer for subarray of size n by 2 and other n by 2 and think of something. Because for example, let's say the first subarray is 14 14 and the next subarray is 11 11. So we cannot, even if we sort the array, the first two will be 11 11, the second will be 14 14. So the answer individually for these both is 0, And if we take the whole array as a sequence, and then the answer will be 2, 11, 14 and 11, 14. So we cannot think of any other size comparison. So now let's think of values. So for example, let's say we have two numbers 5 and 20. In which cases A, B cannot be paired. If A and B are unable to pair, what does it mean? It means that its product is a perfect square. 5 and 20 is 100, which is a perfect square, so that we are unable to pair 5 and 20. So what does it mean? Let's say 5 is A and 20 is B. So if we are unable to pair them, it means that A into B is some perfect square, which is K into K, right? So B can be written as K into K by A, which is some perfect square by A. So if this is the case, then they cannot be paired. And now A, B, K all are integers. So K into K by A is also an integer. So what does it mean? Because A should be cancelled with this, right? Or how we can get an integer? For example, we have 6 into 6 by 11. Is this a possibility to get an integer? No, because we must have a we must have K is equal to some A into K, some A into P, so that A will be divisible and we get an integer. So from this, what we can understand, K must be of some factor, let's assume C here, and into A, so that the denominator will be cancelled and we will get a number which is B, which is integer. So K must be C into A, so C into C into A, because K square, so C square into A square and divided by A. So now what it will give? It will be C square into A. So from this we can understand that B is equal to some perfect square into A. So if this is the case, then we cannot pair AB. So from this, what we can understand, if we try to simplify B as A and A is also A, then if these both values are same, it means that we cannot pair them, right? For example, let's say we have 3 and we have 12. So these, if we cannot take this as a pair, why we cannot take? Because 3 into 12, 36 is a perfect square. So 3 is 3 as usual, but 12 can be written as 3 into 4. So that 4 is a perfect square, right? So these both are already equal and this is a perfect square. So that we are unable to make this a perfect square. So from this we can understand that if we try to simplify a given number to the final number where we cannot divide by any perfect squares, then that can be called as a final value of a number. And if final number values of two numbers are not equal, then we can pair them. If they are equal, we cannot pair them. Let's say example, let's say we have 3, 12 as usual, the before one, and 11, 14, and 3 and 18. So 3 into 12, 3, and we can compress this into only 3, because we'll divide by 4, which is a perfect square. We got 3. Can we divide 3 by any other perfect square other than 1? No. So this is the final number, and these two are equal. So we cannot pair these both. And now let's come to 11. We cannot break this. Even we cannot break this. So these both are not equal, so we can pair. And coming to 3, 3 is 3. And coming to 18. So is 4 divisible by 18? No. Is 9 divisible by 18? Yes. So we can make this to 2. This is the final value. Can we reduce 2 further? No. Because we can start reducing only by dividing by 4. And now what? These both are unequal, so we can make a pair. So from this we got that instead of very big numbers, we can try to reduce all the given numbers, and then we can use their frequencies in a map. So that, for example, so 520 is equal to 55 indirectly, and 5 are indirectly equal to 20, indirectly equal to 45, indirectly equal to 80, because 80 can be converted to 5 by divide by 4 square, and this by 3 square, and this by 2 square. So in this way we can try to we can try to divide until we get numbers. So this is the given array, right? So now what will be the new array? It will be 4 is converted to 1, 12 to 3, and so on. And from this we can understand that the frequency of 5 is 4, frequency of 5 is 5, and frequency of 3 is 1, and frequency of 1 is 1. So for example, 5 frequency 5, what does it mean? We cannot pair any of these 5, because these all are ultimately boiled down to 5. Whether these can be 5, we don't care, or it is 20, we don't care. The final number is 5. So if a number is going to pair with 5, it will be paired with 20 as well. If a number is not able to pair with 5, it will not be able to pair with 20 also. So in this way, all these numbers are equal, and that's why we stored in the map indirectly, independent of the original value. So for example, we have 5, 5 and 3, 1. So what does it mean? Which we can pair? We can pair this one and one from this. So the only answer that we can get is one pair only. 1, 3, 1, 5. Other 4 5s we cannot pair because they all are same number. So if you multiply, we'll get a perfect square. So in this way, we can get the answer. And now let's take a big example. So for example, this is the final frequency map that we got. 1, 3, 2, 5, 5, 4. These can be 2 or 8 or anything. So hope you got this. And now the main things are frequency rate, because in a same frequency we cannot pair together. If two different frequencies are there, we can surely pair together. So the main thing is the frequency, but not the value we have. So we can store in a new vector the frequencies, and then we can sort, because frequency is important, but it is not important which frequency is first or second. So we can sort this without any problem. And now after sorting, let's try to think which to be paired to get the better answer. So let's assume that the vector is 3, 4, 5, which is the frequency. So this is sorted, and now we have 3, 4, 5, 8. So let's try to pair these 3 with 3 in the second one. So we paired all these 3. So the answer is 3 for now. And then what are the things left? 1 and 5 are left. So we can pair these 2 also. So we can get the pair as 1. So the answer is 4 for this case. All these 4 were left. All these 4 were unused. And now let's take other possibility. So let's take these 4 and let's take these 4. 4 in this and 4 in this. And now what will be? It will be 4. And then 1 from this, 1 from this. So we got a new pair. So this is 5. So we got a better answer. Why we switched the case? Because from the first example we got that we are wasting the higher frequency element. Why? Because we have 3, we have 4, we have 5. We paired these 2, and here 1 is left. And now we used 1 and 4 is left. So indirectly it is like we are wasting the higher frequency. So now we start from higher frequency, and now what we have done? 3, 4, 5, 8. So 5, the before one is 4. So we can pair 4 of highest one with the below one, before one. So we paired all these 4 with these 4. So 1 is left. So the answer is 4 till now. And then we took 1 and we took 1 from this. So 5. And we left 2 elements. We got 5 pairs. So in this both, we got the 5, which is optimal. So this is the final answer for this? No. So let's say this is again 3, 4, 5. And now these both can be paired. These both can be paired. And then we got 2 pairs. And other also can be paired. We got 3. 2 plus 1, we got 3. And then we can pair the first one and last one. We can pair first one and second one. And we can pair first one and last one. So we have 3, 4, 5. We can pair 3 of this. And we can pair 3 of this. So now the answer is 3. And what are the things left? Here 3, here 1, and here 2. And now we can pair this one and this one. So we got 4. And we can pair other 2 also. So we have 3, 4, 5, 8. So we can pair these 3 and these 3 first. So it will be 3 pairs. And we have 3, and we have 1, and we have 2. So let's pair these 2 now. So we'll get 2, 0, 2. So we got a 4. And we can pair these 2 with these 2. So we added 2. So the answer is 6. So 12, all these can be paired together. So the answer is 6, but even this is not the case. So why is this failed? And why is this correct? So this is because initially we thought that the answer is dependent on the highest frequency element. But as we are removing the elements, the frequency will change, right? So for example, let's take other one. So we have 3, 4, 5 again. And initially we are concerned about the highest frequency. Now, so we are removing the highest frequency. So this is 4, and we removed the highest second frequency also. This is 3. So we got answer as 1. Answer as 1 pair. And now let's take again this one. So initially 3, 4, 5. So after popping the 2 highest frequencies, even then this is the case. This is highest, this is the second highest, and so we got the answer as 1. And now let's remove, so let's remove 1 from this because both are 3 and 3 are equal, so we can take any of these. So let's assume the first one, and then we are removing this, and then we are removing this. So the answer is 2. And now, even now we are concerned about highest one, but here till now we are considering these two. So we have considered 4 and this now, but now we are considering these two. So it means that as we are popping the elements, the higher number may change. If A and B indexes are highest in the first operation, they may not be highest after Xth operation. Other indices may be highest. So we are thinking about dynamic frequency after removing the elements, but not too frequency highest from the initially. So what can we use here? We can use a heap to find the highest two frequency values so that we are concerned with those. So we are using heap and then we can pop those and we can get the maximum answer possible. So let's take the dry run 3, 4, 5. So initially pop two highest one. So we got 3, 3, 4 and the answer is 1. So pop the next two. Let's assume these two. And now highest are these two. So now you can understand. So for example, till now these two are the highest one. And now these two are the highest one. So obviously we want a heap to get the highest values. We cannot get always these indices because here these two are not highest, so our greedy will fail. So obviously we have to select the highest frequency after operations. So we are using a heap, and now these two are the highest, so we'll pop these two and the answer is 2 and so on. We'll get 2 to 2. We can remove any, let's assume these two are removing and we are getting 1 1, and then remove these two and we are getting 1 0 1 and then 0 0 0, which means that all are paired completely and the answer is 6. So in this way we can maintain a heap, and initially we can push all the map frequencies into heap, and then we can start popping the highest two and removing those frequencies, and if they are more, like if they are not 0, then we can add again into queue, priority queue and so on. But time complexity is unlog n because we are using a heap, and heap accessing the highest element is of log n. But this may give TLE. Why? Because in the before we are trying to boil down the numbers, right? For example, the value is 199 minus 2. We are dividing this number until we are getting a number which cannot be filtered together. So indirectly, the time complexity of this will be n into log of 199, right? So even this may go up to 1e8 or 1 or more than 5e7. So it is better to not use n log n. If we try to get an of n, then it is very good. If it is not, then we can try to substitute this. So let's try to think whether we can get any better answer, any better complexity than of n log n. So in these cases, the first thing is max. So take very small size array and start thinking about different frequencies and so on. So let's take the size as 6. So the main thing is what? The main thing is the maximum frequency of an element. So for now, let's assume that maximum frequency is 1. If the maximum frequency is 1, what it means? Every element has a frequency 1. So that only then maximum frequency will be 1, right? So if it is the case, then what will be the answer? It will be 3. Because if the maximum frequency is 1, we can pair any two numbers, any two pairs. So the answer will be 3. And if the maximum is 2, so let's assume that we have 3 and 3, and we have 5, 6, 7, 11. So the size is 6, so the maximum frequency is 2. Then what we can pair? We can pair 3 with 5 and 3 with 6. So we can pair 3 with 5 and 3 with 6, and we can pair 7, 11. So even in this case, we are able to make all operations. So even now it is 3. And for 3 also, for example, let's assume that 3, 3, 3 and 2, 5, 7. So even in this case, we can remove the highest one with every other. So even now the answer is 3. Now let's take 4. So for example, we have 3, 3, 3, 3 and 5, 7. So now what are the maximum operations possible? We can make these two and we can make these two. But we cannot make these two pair because these both are same. So from this we got that the answer is 2. But for the frequency 1, 2, 3, the answer is 3. For frequency 4, it is 2. And for 5, so let's assume 3, 3, 3, 3, 3 and 5. So even now we can only make one pair. because we cannot make any of these pair. So now the answer is 1. So for 5 answer is 1. And if the frequency is 6, the answer is 0, because all are same numbers, we cannot pair any of them. So if we very clearly observe, what will it say? It will say that up to n by 2, the answer is 3. Up to n by 2, we are able to make all the pairs, so the answer is n by 2 itself. But after 4, the answer is gradually reducing. So up to 3 it is 3, but after 3 it started reducing. So why it started reducing? So it is because, and other important thing is, from this we are able to observe that if the maximum frequency is as less as possible, we are able to get the best answer. Why? Because if the maximum frequency is 1, we are able to achieve 3. But if the maximum frequency is 6, we are able to gain nothing. The answer is 0. So from this, the main thing is we have to reduce, like we can't reduce, but it is best if we have the maximum frequency as less as possible, so that we can pair as many as possible. So that is what, if it is best if the maximum frequency is as less as possible, so we will try to pair more. So if it is n by 2, so for the size 6 and the maximum frequency is 3, so we got that how many numbers are equal to maximum frequency, that many number of other numbers also exist. So if the maximum frequency is 3, what it means, let's assume 3 is the highest frequency with 3 frequency, so 333. And if this is the maximum frequency, any other frequency is less than 3, so it means that there can be 5 or 5 or 557 or anything, because the frequency can be less than or equal to 3. So in this case, all can be paired with higher frequency number. So if the frequency is less than or equal to the size of by 2, it means that we can pair every pair. So the answer will be n by 2. Because from this we are able to clearly observe that if the frequency is exactly less than or equal to n by 2, we can pair the highest frequency number with any other value, so that the answer will be n by 2. So for example, let's take odd frequency. For example, we have n is equal to 5. So for odd, there may be a different case. So if the frequency is 2, if the highest frequency is 2, if the highest frequency is 3. So if it is 2, what it means? So 3, 3 and 5, 7, 11. And now what will be the answer? It will be 2, which is n by 2. Because for 5 the answer is 2, so it means n by 2. But we are wasting 1. So indirectly it is that n by 2 only. So if the frequency of the maximum frequency is less than or equal to n by 2, it means that we are able to form all the pairs and the answer is n by 2. But as the frequency is going to be greater than n by 2, then the answer will be reducing. Why? Let's assume the size is 100. So let's assume the size is 100 and the maximum frequency is 80. So it means that all 80 elements are equal and rest 20 elements are different. Maybe different or they may be equal, but it will be not equal to this number. So, but now what can be observed? We can pair all these 20 with 20 of the maximum one, and these other 60 will be left because we cannot pair those. So now what will be answer? It will be 20 here. And what is 20? It is n minus the maximum frequency. So n minus maximum frequency will be our answer. So we got an approach how to solve this, but we forgot k, right? Because till now we did not discuss about k. Till now we are able to get the solution without k. So what does it mean? It means that answer is the before answer we found is simply the answer when k is equal to 0. But now k can be anything. And now how can we solve this? So we discussed that k when k can be useful. For example, if the maximum frequency is 3 for n is equal to 10, it means that we can pair all the pairs even without k. So k will be used only if the frequency is greater than n by 2, so that there will be some numbers left and then we can try to utilize those. So firstly, k is required only if frequency is greater than n by 2. If it is not, we can simply return n by 2, which is the maximum answer ever possible. So for example, let's assume n is equal to 100 and maximum frequency is 80 and the answer is 20. Why 20? Because we have 80 and the left is 20. So n minus frequency is 20. So we can pair only these 20. So the answer is 24 now. And what are the wasted numbers that are left? It is simply 80 minus 20 because the maximum frequency minus this one. So 60 is the number of maximum frequency left which are unable to pair with any other. So for example, these left are 60, right? So for example, k is equal to 100. So if k is equal to 100, what it means? We can make these 60 every individual other number. For example, if k is equal to 100 and we have left is equal to 60. So what does it mean? We can make 100 operations where in each operation we can change any number to any other number. So for 60, what I will do? We can convert the first number to 1, second number to 2, third to 3, fourth to 5 and so on. So in this way, we can make all these as different numbers. So we can pair every other now. So from this, we can utilize the fact that the extra answer because of k will be simply minimum of left by 2 and k. Why minimum? So for example, the left is 60. The left is 60 and k is 30 and k is 20 and k is 500. So if k is far more than 60, we can pair all those. So it will be minimum of both, which will be 60. And we are dividing by 2 because we are thinking about place. So if k is more than the left by 2, it means that we can pair every other. So the answer is simply 30. So minimum of these left by 2 and then 500. And if it is less than this, we can use only k operations. So we can form only 20 pairs. So in these 60, we will convert only 20. And even now 40 are left, but we cannot utilize those. We can utilize only 20, which is equal to k. And if these both are equal, anything is fine. So from this we are able to understand that the answer is simply minimum of left by 2 and k. So all these can be transformed to some other prime numbers so that all those can be primed internally. All those can be coupled internally. So hope you got this. Let's check the code. So simply we are inputting n and k and we are storing the ultimate boiled down number in the map, and then we are finding the maximum frequency, and extra is the number of numbers left where 60 in the, for example. So if the when extra will be there only if maximum number frequency is greater than n by 2. So initially it is 0, and if it is greater than n by 2, then make extra is equal to the maximum minus n by 2, which is the 80 minus 20, which is 60, and then answer will be n minus mx, which will be 80 minus 100 minus 80, which is 20. So we got the answer. And if mx is less than or equal to n by 2, the answer is n by 2. And if it is mod 2 is 1, if it is odd, reduce 1. And finally, what is the answer that we are able to achieve from k? It is simply minimum of extra by 2 and k. So simply print this. In this way, we can find the answer. If you have any doubts, comment below. See you in the next video.